A very good morning to everyone. Am I audible? Hello. Am I audible? Am I audible? Hello.
Yes, sir, you are audible.
Hello, good morning, everyone. Am I audible?
Yes, sir.
Hello, am I audible?
Hello. Good morning. Am I audible? Okay, okay. Thank you, sir. Okay. Sorry for interruption. So, today is a great day. Good morning to all my dear student, respected colleague, and the guest. It gives me immense to joy welcome you all to the 5-day student enrichment program, an initiative born out of our shared vision to sharpen mind, strengthen skill, and save the future of our young technocrat. This program has been thoughtfully cultured to offer not just academic support, but intellectual enrichment, holistic perspective, and competitive edge, especially for those preparing for national level challenges like GATE. Before we begin, allow me to introduce myself. I am Mr. Swarup Kumar Hajra Chaudhary, Head of the Department of Computer Science Engineering, Artificial Intelligence and Machine Learning at Bengal College of Engineering and Technology. It has been my earnest pursuit to ensure that learning in our department goes beyond the textbook into realm of exploration, innovation, and application. With year of academic and technical mentorship behind me, I firmly believe that knowledge, when nurtured with discipline and passion, become power, the power to transform careers and life. And today, I feel proud to introduce a speaker who truly embodies that spirit of transformation, Mr. Prasanna Roy, Assistant Professor, Department of CSC, Bengal College of Engineering and Technology. Mr. Roy is a seasoned professional whose journey span across sectors and discipline. He began as a school teacher, spending nearly 5 years of inspiring young minds and laying strong educational foundation. His tenure in the healthcare industry as a senior administrative manager added layers of operational insight in discipline and people management in his already dynamic profile. Now, as an assistant professor with over 1 year, 6 months of experience in higher education of Mr. Roy continues to bring his multifaceted knowledge in the classroom. He teaches not only with information but with perspective, integrating practical experience, logical depth, strategic clarity, exactly what is needed for success in exam like GATE. So dear student, I urge you to be fully present in today's session, ask questions, take notes, be curious because mentors like Mr. Roy are here not just to teach but to empower. Let us now begin today's journey of our enrichment program with open minds and ready heart. With great honor and enthusiasm, I welcome Mr. Roy to take the session forward. Over to you, Mr. Roy, sir.
Thank you, sir, for the great introduction. Thank you so much.
Thank you, sir.
Okay, a very good morning to all my students. Thank you for being present in this session. So, with any further delay, we will go into the topic. Okay, just a minute. I am sharing my screen with you all. I hope that I am audible to all of you. Am I audible to all of you? Okay, thank you. Just a minute. Let me share my screen. Now is it okay, sir? Okay, is my screen visible? Okay. Okay. So good morning to all of you, dear students. Please be in the session and be interactive during our session. So as already Mr. Swarup sir has introduced me, I am the Assistant Professor of Bengal College of Engineering and Technology and serving in this institute for last 1.5 years. So today we will focus mainly on the topic operating system. And as I know that there are many students who have not yet went through this subject, so I will be sticking to the basics so that everyone can understand. Because the audience that is present here are maybe from the pass out batch, they may be from the final year and also from the pre-final year. Okay, so you know that operating system is a very important topic for the GATE examination, and also you know that in our day-to-day life, because without the operating system, it is impossible to run a computer. Because you know that it is the first thing that is required to be installed in any kind of hardware, because it is the interface between the computer system, the hardware, and the application software. So it works as an interface. So without it, we cannot do anything. So just a quick glimpse of the, just a minute, I'm having some problem, just a minute. Okay, so you know that the importance of operating system can be understood from this quotation. So you know that the religious head of the Christian community, he was once the head of the Christian community, Pope Benedict XVI. So he said that you must know your faith with the same precision with which a specialist in IT knows the operating system of a computer. So you can understand that it is a very important subject, and without this, you cannot become an IT specialist. And as per the GATE syllabus is concerned, a lot of questions is coming from this part of the topic. So we move on directly to the topics that actually come. Okay. So these are the broad topics that are covered. One is process management. Okay, where you understand what are the different kind of schedulers. Okay, and how processes are created, what are the different states of the process. Then we go to the CPU scheduling. So what is CPU scheduling? In this part, actually what happens, there are different kind of algorithms that tell you how the different processes that are going to be executed in the processor are scheduled. Then inter-process communication. Then so nowadays we are talking about the multitasking operating system, and various processes are running at the same time. So how these processes communicate with each other. Then deadlock is there. Okay, what is deadlock? It is a kind of situation where two processes try to get the same resource, and how this problem can be solved. If there is only one resource, then how it will be allocated to a particular process. Then memory management, how the memory is managed. Okay, here we are mainly concerned about the primary memory of the computer. Then disk scheduling, how the disk will be scheduled, and finally the program evolution. Now, it is a very true fact that in a single session, it is not possible to cover all these topics. So today I am mainly focused on the process part. Okay, so that we will be doing today. So the first thing that we are going to do is, what is a process? Can anyone tell me what a process is? Any idea? Anyone? Those who have
Program in execution.
Yes, so it is a program in execution. Whenever a program is not executing, it is just known as a program, and whenever it comes into execution, it becomes a process. Okay, so whenever a new process is created, So these are the few things that happen. You can see on your screen. So first of all, the PCB of the process is created. It is the process control block. We will do this in detail, okay, in the coming part of the session. Then a process ID is assigned to it. What is this process ID? It is a unique number by which the computer identifies that it is a process. Okay, and then the priority. So there are priorities also assigned, which process will be executed before whom. So this kind of priority are also given. Now, whenever a process is created, at the same time, the memory is also allocated. Okay, and other resources are allocated to the process. Then finally, the process environment is set up and the accounting information. Okay, so what the process is doing, what is being done, all these things are also accounted in this manner. Okay, so let us go to the phases. So what actually happens? Okay, so these are the various states of the process. Okay, so the first one is the block state. So any idea when this block state is encountered by a process? Can anyone tell me? Any idea? Okay, so I am telling you. So what happens sometimes when a process is there, it is working, it might wait for some event to occur, like some input it might require from the keyboard or from some other device. So during this time, the process cannot execute. So at that time, what will happen? The process will be sent to the block state. Okay. So during this time, it doesn't require the services of the CPU. So this is the first one that we are doing. So second one is the ready. So a process is in the ready state when it is ready to run, but still now it is not allocated the CPU. Okay, so it will be ready, that it is waiting that the CPU will be allocated, but still now it is not allocated the CPU. Then the third one is the running state. So in the running state, what will happen? The process will start executing. Okay, so remember one thing, if there is only one CPU, that is the processor, only one process can execute at a time. Now it will depend on how many CPUs are there or how many processors are there. Suppose if there are n CPU, so n number of processes can execute at a time. So the philosophy is that only one process can execute at a time in the CPU. Okay. Then the next one is, after it is in the running state, once it has completed all the execution and everything, if it is completed, what will happen? It will go to the terminated or exit state. Okay, that is the fourth state. So what will happen? The execution will be halted. Okay, but the record will be still kept. Okay, in the operating system, like the PCB will be still maintained. And finally, the new one is that again, whenever the new process will come, it will go to this state. So these are the different states. Okay, so what is the current activity of the process? Whenever a process is executing, what is the current activity? That is the state of the process. So up to this part, if you have any kind of query, any kind of question, you can ask me. Was it clear to all of you?
Yes.
Okay. Thank you. So please be interactive with me. If you have any kind of question, feel free to ask. So in the next part, we are going to look at this transition diagram. Just a minute. Okay, so this is the state transition diagram. So what are the transitions that are occurring in the lifetime of the process? Okay, so you see, the first one is the, like, this is a diagram, so try to understand. The process has entered into the new state, and once it is admitted, it will go to the ready state. From here, okay, two things can happen. So it can be either dispatched to the running state. After it goes to the running state, and if the time up is there, so we will do the scheduling also, we will try to cover today. Time up means suppose we have allocated some time for execution using some kind of algorithm, say round robin. So round robin is a very famous algorithm where like specific time quantum is allocated to each and every process. Suppose say 5 milliseconds for each process I have allocated. Now once the 5 millisecond for a particular process is over, then it will be again going back to the ready state. Okay, maybe the process has still now not executed totally. Maybe the total time execution is 15 milliseconds. So after 5 milliseconds, it will come back to the ready state. Okay, so sometimes there may be during the running state, there is a IO request, as I told you. So some input is required. So it will go to the blocked state. That means the execution is not yet completed. Now from the blocked state, it will not directly come back to the running state. It will again go to the ready state, and again from there it will be dispatched to the running state. And finally, when it will be terminated, halt, or somehow killed, okay, forcefully, it will go to the halted state. So this is the total state transition diagram, how the transition of the various states will occur, that has been shown. Okay. So next we will move on to the process control block. So here you can see a structure that represents the process control block. Okay. So what actually this process control block, this stores all the information regarding a process that has been created by the operating system. Okay, so the first one is the process ID. So this is like a ticket or a token that is allocated by the operating system to the process on creation. After a process is created, this token will be allocated to the process by the operating system. Okay. The next one is the process state. So what is the process state? We have already discussed the different process state. So by looking at this field, we can come to know in which particular process state the process is in, is at this instant. Like it may be in the running state or ready state. So that information will be there. Then the priority of the process. So what is the priority of the process? Maybe in your system there are some processes which are very urgent, which are very high priority than the other processes. Okay, like one example I'll give you. Suppose you are going to some place, okay, by your bike or by car. So suddenly the prime minister of the country passes through that road. So what will happen? So you will not get the priority to cross the road at that time, because the prime minister of the country is a VIP, so he will get the priority. Okay, so this is the concept. Okay, so students, I will request you to switch off your video and do not switch on until and unless you make a special request. Okay, so if you want to switch on your video, you can ask me, and if you have something to tell. Okay, next is the register save area. So in the register save area, what happens? So whenever there is a switching, like what, suppose a higher priority process comes, there a situation happens known as the context switching, or the time quantum of the process is completed, the context switching happens. So what is this context switching? Suppose a process P1 is running. Okay, I am naming the process as P1. Now a higher priority process comes. This P1 process is still not complete. So what will happen? This process will be switched to P2. Okay, the control will be switched to P2. Now, till now, the progress of P1 will be stored in the registers save area. Okay, my slide is not visible. Sir, is it showing process control block? Oh yes, I am in that topic only. Sir, I have not finished my topic till now. I am explaining the things. Okay. Then all the list of open files will be there. What are the different files that the process is using? Okay. Then the accounting information, any other information, like any other information means something that is with regard to the directory that contains the path name, okay, from where the process is running. All these things will be there. Okay. Okay. So this is all about the process control block. Now, we have already talked about the scheduling part. So I told you that there are different types of scheduler. Because the process, what happens? The process will migrate between various scheduling queue throughout its lifetime. So there are different scheduling techniques that will be used to do this work. So mainly there are three types of schedulers. One is the long-term scheduler, which is also known as the job scheduler. Then the medium-term scheduler, which is also known as the swapper. And the last one is the short-term scheduler, which is known as the dispatcher. So these things we have more or less seen in the state transition diagram, that there are different kind of scheduling algorithms that will be running. Otherwise, how your process will be going from one state to another state. Okay. So what is a long-term scheduler? Actually, long-term in scheduling, what happens? All the processes are kept in a pool, like they are kept ready that sometime they will get the processor. Okay. In case of medium-term scheduler, it totally depends upon the availability of the main memory. Okay. Sometimes there may be some kind of swapping. Okay. And in case of short-term scheduler, what happens? Suppose a program goes to the ready queue, okay, ready state. So, or it is in the like a block state for some IO operation. So anytime whenever that request will be completed, it will again be scheduled to the processor. So this is done by the short-term scheduler. So from that thing you can understand, it totally depends upon the situation when the scheduling will take place. Okay. Now, till this, do you have any kind of question you can ask me?
Sir, can you just tell us once again the different functions of the schedulers?
Different functions of the schedulers. Okay. So you see there are mainly three kinds of schedulers. Can you see that? So one is the long-term scheduler. Okay. So what is actually the work of the long-term schedulers? See, your program, before it becomes a process, all these programs are stored in some kind of storage device. Okay. So they are waiting for execution for a later time. So the work of the long-time scheduler is to select the process from this pool and load them into the memory for kind of execution. Okay, it will select all the processes that are waiting or the programs that are going to become a process from the memory, and they will be they will be selected from the disk and they will be sent to the memory. So this is the work of the long-term scheduler. Did you understand this part?
Yes, sir. That means from the new state, it is happening actually.
No. Till now, it is there in the pool. Okay. Yes, it is in the new state right now.
Yes.
Okay. Then the medium-term scheduler. In the medium-term scheduler, what happens? Okay. So already your process is there in the main memory. It has come. Okay. Now in the main memory, all the processes has not come. Only a limited number that has been selected by the long-term scheduler, they have come. Okay. So now what will happen? These processes, they will go to the ready state or some kind of IO like requirement is there. So they will be done with the help of the medium-term scheduler. Now, suppose your IO request is also completed, everything is completed, the process was there in the block state. In those places, the short-term scheduler or the dispatcher will work. Okay.
That means from ready state to the running state, basically we are using the medium-term scheduler, right,
Yes.
sir?
Okay, so I will show you another state diagram, okay, which has been modified with the help of the different kind of schedulers. So before
Okay,
that,
sir, I'm eager to see that.
yes. So before that, we are going to see that. See, this is the thing, how it is working. So here you can see, is it visible where the different schedulers are working?
Yes, sir.
Okay, so you can see whenever the process is coming to the new state, the long-term scheduler is working. It is going to the ready state. Okay, from the ready state, the short-term scheduler is working. And suppose you are going to the block state. Again, when it will come back to the ready state, the medium-term scheduler will be working. So it has been shown with the symbols S, M, and L. Okay.
That means the ready state to running state is brought by short-term scheduler.
Yes. Now from the ready state, whenever the process enters the ready state, after that it will be allocated the processor. Okay, so this part, it will be handled by the short-term scheduler. Is it okay?
Yes, sir.
Okay. Okay. Now let us take up a question now. Now it is your turn to solve a question. So this is our first question that we are going to solve. Okay, the question is, where does the dispatcher reside? In RAM or main memory, in cache memory, in hard disk, in external or auxiliary memory device?
Main memory.
In
Main memory.
RAM or main memory? Okay, so this is the answer you have given. I am waiting for the others also. Do you agree? Do you agree? The other students, other participants who are present?
Yes, sir.
Okay. So can anyone tell me what is the reason for this?
So main memory is the repository of all information. So an external device or hard disk, these are absolutely not feasible options because they are not directly connected. They are connected through other means.
Actually, you know one thing, that whenever something is going to execute in the CPU, can the CPU directly communicate with secondary storage devices?
Absolutely no.
Absolutely no. Okay. So anything before the process has to come to the CPU, it has to get loaded into the main memory. It has to come to the RAM. Okay. And why B option is not possible? Any idea? Why the
It's a
cache?
very less space. It's a very less space is present in the cache memory, which has to be given to other more important tasks or data.
Okay. Okay. So you are absolutely correct. So up to this, till whatever we have covered, is there any doubt? Anything that you want to ask?
Yes, I would like to ask once about the medium-term scheduler. So that means, so when the process is going to the block state, then
Yes.
sir, after, how is the medium-term scheduler able to realize or recognize that it has to be sent back to the ready state? So that is my question.
See, it will, all the information is there in the PCB. The PCB will show that it is not yet complete, right? So that's
Yes,
why
sir.
it was sent to the block state. Now, when a process is in the block state, immediately it will not get the CPU, because maybe some another process is running in the CPU, getting executed in the CPU. So again, it is going back to the ready state, because see, try to understand from the name. Whenever you are going to the ready state from the block state, that means immediately you are not getting the CPU. You have to wait for some time. The process has to wait for some time, right?
Yes, definitely, until a
Okay.
processor is free.
And all this information is there in the PCB. That is why the PCB is maintained. Because the ready, whatever state information, currently in which state the process is there, is also there in the PCB. If you look at the structure of the PCB.
Yes, it is there.
Okay. So was it okay?
Yes, yes.
Okay, so I'm moving on to the next part. Okay, so we already talked about this context switching. So is it necessary? Can anyone tell me? We could have completed a single process, isn't it? Once a process is going to the CPU, whatever time it takes or whatever happens, we could have done that. Is it necessary?
Sir, if
Can
the
anyone?
process is very long, then sir, it may be necessary.
Okay, so it is necessary for many cases. Like number one, if the process is too long, okay, so it will take a lot of time and maybe the efficiency of the CPU may be reduced. This is number one. Number two, whenever a process is going to the block state, okay, maybe there is no context switching. Imagine that there is no context switching. So what will happen? The CPU will remain idle, nothing will happen. So you know that the CPU is a very costly resource. So during the time the CPU is sitting idle, so a lot of like efficiency will be wasted. So context switching is necessary. Okay. So this is the concept of context switching. In context switching, what will happen? So whenever context switching will occur, the current state of the old process will be saved. Okay. And the saved state of the new process will be looked at. So previously in what state the saved process was, that will be looked at. So this whole thing is known as context switching. Okay, so context switching is also taken care by the PCB. So it will have the information in which current state the process is there. So this is the concept of concept switching, but there is a problem also. Context switching is kind of a overhead. Can anyone tell me what is the reason why it is considered to be a overhead? But we have to do this overhead. We don't have any choice. Why it
Sir,
is a
too
overhead?
many times, sir, we have to store the resources elsewhere and then again bring the resources from elsewhere. This is time-consuming process, and also it
No,
is
no,
going to
that
lead
is.
to
See, I
yes.
understood what you are saying. You are like a little bit correct, but that we have to do. That is the consequence of context switching. I am asking that context switching is an overhead that you can understand. It is not something that is actually required, but we have to do. It is a necessity. At the same time, it is not required. But the question is that why it is considered to be an overhead? Any idea? Okay, I am giving you one hint. Okay, not the hint, I am giving you the answer. During context switching, any work is happening, any kind of task is happening, any useful work is being done in the system.
No, no, no,
No,
nothing is
nothing,
happening.
No, sir.
nothing is happening. Okay, so that is why it is considered to be a overhead, but at the same time, it is necessary. We cannot go away from it. Otherwise, what will happen? The CPU will remain idle. We have to allocate the CPU to some other process during the meantime when this thing is happening. Okay. Now with this, we are going to another question. Can you see the question on your screen?
Yes, sir.
Okay. So what will be the answer of this?
FIFO data register.
Yes?
FIFO data register.
Yes, it should be
FIFO.
FIFO.
Vote for it. Who all are telling LIFO, who all are telling FIFO? Only two options are there.
Sir, I would go for FIFO.
You will go for FIFO. FIFO
Yes.
is,
Sir, I think LIFO data structure.
why you think LIFO data structure? Why FIFO and why LIFO? What is the reason? Just give me reason. Those who all are telling FIFO, why FIFO and why LIFO?
Sir, FIFO because a process which comes first to the memory should be the first one to get executed if not preempted.
No, here it is written process context, not the process. Try to understand. Process context. Okay, you tell me which data structure the computer operating system maintains. Any idea? How the operating system works with which data structure? FIFO is a concept of which data structure, queue or stack?
FIFO is for Q, sir.
Queue. And LIFO for stack?
Stack.
Stack.
Okay. So what happens in any kind of operating system, all these things are maintained using a stack, not by a queue. So the answer will be LIFO. The LIFO data structure will maintain it like it will maintain it in the LIFO data structure. That is the concept. The operating system will maintain it in the LIFO data structure. Okay. Okay. So let us go to the next part. Okay, so we will go to the next part, that is CPU scheduling. Okay. So as we have already discussed, CPU scheduling is something that is very important for a multi-programming environment. Otherwise, you will not get the feeling that more than one task is like executing at the same time, or more than one process is getting executed at the same time. Okay. So what actually happens? This concept of multi-programming is very simple. Like what will happen? Suppose a process is getting executed. Okay. So it will get executed until and unless some another preemptive or some higher priority process is coming, or this process requires some IO. And whenever it will require some IO, what will happen? It will directly go to the waiting state. Okay. So in a multi-programming environment, what will happen? Several processes will be kept at the same time in the memory. Okay, by memory, we are always talking about the random access memory or the RAM. Okay, so whenever I talk about memory, try to understand it is the primary memory of the computer or the RAM of the computer. So multiple processes will be there in the memory at that same time. So when one process has to wait, what the CPU will do? I told you that it will not keep the operating system, it will not keep the CPU idle. Okay, so it will give the CPU to another process. Okay, and like this, it will continue. This current process, whenever it will require some IO, it will again go to the waiting state, or it will go to the block state, sorry. Afterwards, it will come to the waiting state, and again, this CPU will be allocated to the another process. So for this, what happens? There is something known as the CPU IO burst cycle. Okay, so it is like a continuous cycle that is happening. Okay, sometime the process that will be executed will go to the CPU for the execution. Again, it will go to the block state for the IO, and this will go on continuing continuously. So we are going to the next slide. You will understand. This is the CPU IO burst cycle. Okay, so you can see one thing. So suppose some data is loaded. Okay, some process is like some add process is happening. This will happen where? It will be happened in the CPU. Okay, now again it want to read something from the file or from some input output device. It will wait for the IO. This is the IO burst. Again, it will store that. Again, it will go to the CPU, increment the index, write to the file. So all the execution part is happening with the help of the CPU. It is happening in the CPU. And whenever it will require some input output, the input output device can be anything. It can be the keyboard. It can be the file also that is stored in your computer. So at that time, it will go on changing from the CPU bus to the IO bus, and this cycle will continuously happen. Okay. So tell me if you have any kind of doubt in this part. Any question, any doubt? So
So can you just summarize once again?
okay, I'll summarize once again. What is actually happening, I told you that whenever some process will require the IO, okay, so it has to go to the block state. So in the meantime, what will happen? The operating system will not keep the CPU idle. Okay, because I told you it is a very expensive resource. The CPU is very expensive. So what will happen? It will allocate another process to it. So that process is getting executed, but that process that was sent to the block state, whenever the IO request is complete, again it will become ready to enter into the CPU. So this will go on. You look at the diagram, one example is given, like suppose the data loading operation, suppose some addition operation, suppose some file reading operation, all these are execution part. This will happen in the CPU burst, okay, in the CPU. Now suddenly the process will require some kind of input output. At that time, what will happen? It will go to the block state, it will wait for the IO. Once this thing is satisfied, it will again come to the CPU, isn't it? So this will go on, this will go on. So it is coming to the CPU, again it is going to the IO, again it is coming to the CPU, like this it will go on. So this is known as CPU IO burst cycle, until and unless the whole thing is completed. And if you look into, if you take into consideration more than one process, it will be like a cycle, it will never stop. Some process is getting executed, some process is waiting for the input output. Okay?
Yes.
Yes, sir.
Okay. Now, again, another question for you, a very easy one.
Sir, true, sir.
It is true. So you know that you are experienced.
Yes.
Okay. From your childhood, you are playing different kind of games. You are using various heavy, like high configuration software. So you might be knowing that if you increase main memory, so multi-programming, the degree of multi-programming will also increase. Okay. So this was a very simple question. Okay. Very good. So let us go to the next part. So the next one is process scheduling. So what actually process scheduling is? So you know that when a process is in the running state, okay, the operating system has to decide. So there are many processes that will be waiting to get the CPU. They have all come to the runnable state. So the operating system has to decide which process will run first. This is a very tough job. Okay, so the operating system is like a decision maker. So the part of the operating system that will take care of all these things is the scheduler. Okay, and this scheduler, how it will do? So for this, there are different kind of scheduling algorithms that are available. Okay, so again, try to understand. Again, I am summarizing so that you can understand it again. There are many processes that are waiting to get the CPU. Okay, suppose n number of processes are there. Now you know that the operating system works as a manager. So this manager has to take decision that which particular process will go to the CPU, because we have already discussed that one CPU can only process one process at a time. Okay, it can execute only one process at a time. If you want more than one process to be executed, you have to increase the number of CPU. So considering that there is only one CPU, it is the task of the operating system to decide which particular process will be allocated the CPU first. So who will do this? This will be done by the scheduler. Now how it will be done? For this, the scheduler will use different kinds of scheduling algorithms. Okay. So it is a kind of, that is why I have written, it is a kind of decision making policy. It is not a mechanism. Okay, it is not a mechanism. It is not that like there is a step-by-step process it will happen. It is a decision making policy which process will be allocated the CPU first. Now, how this decision will be made? For these various criteria are taken care by the operating system. Okay. So if you see the criteria, it will become much more clear to you. Okay. So these are the different criteria that will be taken care by the CPU. So first one that we will talk about is the CPU utilization. Okay. So what it will do, it will consider the percentage of time the CPU is executing a process. Okay. So like what is the like time utilization of the CPU by a particular process? Then not only this, it will also have to balance this. So balanced utilization. So each and every process, okay, or all the resource, they will get the same type of, not the same type, but a balanced amount of time so that they can be utilized. Okay. So not only the operating system will see the CPU, it will also check what is the memory utilization, what is the input output utilization, because the CPU is not the only resource. There are many other resources also, like the main memory is there, the IO devices are there, the different kind of devices are, the other resources are there. So it will take into consideration everything. Okay. Next is the throughput. What is throughput? So if we define throughput, it is actually the number of processes the system can execute in a given time period. Okay, that time period can be anything. Within that time period, how many processes are executed by the CPU? Okay, now for this, what will happen? The operating system will take into consideration the average length of a process. By length, what we mean? By length, we mean the execution time, the total completion time that is required by a process to complete the execution. Okay. Suppose, for example, if the processes are very long, what will happen? The throughput will decrease. And on the other hand, the throughput will increase in case the processes are short. Very simple. Like in a certain time period, how many processes can be executed? Okay. Now the next one is the turnaround time. Okay. In turnaround time, what will be considered? The average time period it will take for a process to execute. Okay. So everything it will take into consideration everything, like the time it spends in the system, a particular process spends in the system. Okay. So all these things will be calculated, taken into consideration. Now, one thing remember, this turnaround time will be always inversely proportional to the throughput, because you can understand, as I have already discussed, throughput will decrease if the length of the process is long. Okay, and so the process is becoming lengthy. That means its turnaround time in the system will be also long. Okay, so in that case, what will happen? The throughput will decrease. But in case the process is short, that means the turnaround time will be small. So in that case, the throughput will increase. So you can understand the relationship between the turnaround time and the throughput is that they are inversely proportional. Okay. Then what is waiting time? It is the average time that is spent by a process in waiting. Okay. So this we will see, like we will do some small numericals also on this in the next part of the session. Then the response time. So what is response time? So the average time it takes the system to start responding to the input. For in case of an interactive system, suppose your process wants to take some input. So what is the average time it will take for the system to start responding to the user input? Okay. Then predictability. So what is predictability? For example, there is an interactive system that responds within a second, for example. But on occasion, it can also take 10 seconds to respond. Suppose it is responding within 1 second, but there are few moments where it is taking 10 seconds, around 10 seconds to respond. So you can understand that this is a situation that is not favorable. That is, your response is taking a lot of time. So most of the time, maybe there is a situation that it is responding within 2 seconds. Okay. So what will happen? What the user will do? So in this case, the user will always prefer the system that is responding within 2 seconds. Okay. So there is something called fairness also. What is fairness? The degree to which all processes are given equal opportunity to execute. Okay, so these are something that will be taken into consideration. So suppose there is a situation called starvation. You know what is starvation? Suppose you are hungry and you are not given food. So the same thing happens in case of the process also. Here also we encounter something known as starvation. That means the process is waiting for a long time. Okay, so and it is not getting the chance to execute. So that also has to be taken care by the operating system or the scheduling algorithm. And finally, the priority. We have already discussed what is priority. There are many processes that are of higher priority with respect to the other processes. So in that case, they will be executed first. Okay. So
well, sir, I have a question.
Yes.
Sir, you have mentioned both CPU utilization and balanced utilization
Yes.
in two different bullet points. So
Yes.
can you just tell us, please, what is the difference and so why you have mentioned them in separate bullet points?
There is a lot of difference. CPU utilization is only with respect to the CPU, and balanced utilization is with respect to the CPU and other resources like the main memory, okay, the input output devices. That is why. Okay.
Yes, sir.
Okay. So let us go to the next part. Okay. So these are the mainly two scheduling philosophies that we will encounter. That is, one is the preemptive and another one is the non-preemptive. Okay. So in preemptive scheduling, non-preemptive scheduling, what will happen? So suppose a running process is there in the CPU. Okay, all the resources have been allocated. Okay. So it will not be taken out of the CPU until and unless it will surrender itself to the operating system. That is, it will depend on the process to surrender. It will not be taken out forcefully. Okay. Suppose you are using for this I am taking the example of a bathroom. Okay, bathroom is something like you are using until and unless you leave the bathroom, you cannot be forcefully taken out of the bathroom. So the same thing is happening here. Try to understand the analogy of this with real life situation. Okay. Here what will happen? The process will be allocated the CPU. Okay, the process will be allocated all the other resources, and it will not be taken out of the CPU. Its control will not be captured by the operating system unless it does it on its own. That means even if the higher priority process will come, okay, it will not be forced to give up the control. That is it. Okay. Did you understand this part? Any doubt regarding this? If you have
Understood, sir.
Okay. Okay, I am getting response only from one boy. Okay, his name is Saksar Das. So I would also like to get the response from others also. Be interactive. Okay, if you have any kind of doubt, feel free to ask. Then what is preemptive? In preemptive, the opposite thing will happen. Okay. So suppose a higher priority process will come. The process that is already there in the CPU, it will be preempted. It will be taken out of the CPU. So not only for higher priority process, it can also happen if the time quantum that has been allocated for that particular process is over. Okay, like if I have used the round robin scheduling. So we will talk about the round robin scheduling also. What is round robin scheduling? So in that case, a particular time quantum is allocated to each and every process to get executed in the CPU. Okay, as I have already discussed, suppose there is a process of length 10 millisecond and I have given the time quantum as 2 millisecond. After 2 millisecond, this process will be taken out of the CPU and the next process will get the chance to enter the CPU. Okay, this is one situation. Another situation is that if some higher priority process come, okay, like I told you, like you are crossing the road, you have lot of work to do. You know, there is another thing that you encounter in your day-to-day life sometimes. That is when you are crossing a rail line. Okay, so if the train is coming, whatever may be the traffic, that part they will close the rail gate and you will not be able to pass because train is of higher priority on the rail track. Okay, that is a kind of preemption. People are crossing the road, suddenly the gate will be closed and they will not be allowed to enter. Okay, so this is the concept of preemptive scheduling. So do you have any kind of question regarding preemptive and non-preemptive scheduling?
No, sir.
Okay. Now let us go to round robin scheduling. So what is round robin scheduling? We have already discussed. So in round robin scheduling, what will happen?
Sir, before we proceed, sir, one question. So can an algorithm become means converted from preemptive to non-preemptive in the middle of operations?
Algorithm can be converted to preemptive and non-preemptive means I didn't understand your question.
Sir, I want to say, sir, for example, CPU is executing one form of scheduling algorithm. Sir,
Okay.
that algorithm has been determined to be either one of the types, like preemptive or non-preemptive. So can we interchange the category in the middle of the execution? Like, can we convert the preemptive algorithm into non-preemptive algorithm? Or can the CPU detect and do such a thing?
No, like already the execution is happening and you have already chosen an algorithm. That you
Yes,
want to
sir.
ask. So
Yes, sir. Yes, sir.
see, I am not very sure about this. I'll not misguide you, but as per my knowledge or concept, I know that see the operating system is choosing an algorithm, right? So it is working. So
Yes, sir.
you are saying that that algorithm will be suddenly changed, right?
Yes, or maybe from preemptive to non-preemptive. Like previously, the higher
Yes,
priority
now
processes were
I have
getting
understood
priority,
your question.
and
But
later
truly
on we are
speaking,
allowing everything to
yes,
process.
truly speaking, as per my concept, I don't have any idea regarding this. Okay, so I will not tell you that it will not happen. I will also not tell you that it will happen. Okay, because I am not sure about this, truly speaking. Okay, but it was a very good question. I will try to do a research on this. Okay, thank you.
Okay, sir. Okay,
Okay.
sir. I will be in touch with you, sir.
Okay. You get in touch with me. I also don't have any idea regarding this, but the question was very tricky and very good. Okay. So I have also never thought about this question. Very good question from your side.
Sir, are you
So,
on
but
LinkedIn? Then I will connect with you soon.
yes. So, but see, today I am your
Okay.
resource person. So, as a resource person, I will not try to misguide you because I don't have any idea regarding this. Okay. But your question was very good. Okay, we will try to solve it. So you get in touch with me. Both
Okay,
of us
sir.
will try to see the answer to this.
Yes, sir. I am interested, sir.
Okay, maybe we can search it in the Google, but see, as the session is going on, it is not the fair thing, right?
Yes, sir. Let's proceed.
Okay, it was a very good question. Thank you. Okay. Now, so next one is the round robin scheduling. So this is the first type of scheduling that we will talk about. So try to understand it is one of the oldest and simplest and most widely used algorithm that is used by the operating system. So in this case, what will happen? Each process will be assigned a time interval. Okay, a fixed time interval. Okay, this time interval is known as the time quantum during which this process is allowed to run. Okay, so that will be decided by the operating system how much time will be allocated, and during that time it will run in the operating system, and after the time is completed it will be sent to the block state and again finally sorry, it will not be sent to the block state. If you don't want any IO, it will be sent to the ready state again. Okay, and this will go on one by one until the process is completed. Okay, so very simple. So based on this, let us take up a question. Okay, please analyze the question and tell me what is the answer.
All of them.
All of the above?
Yes, sir. All of them.
Okay, so if you can appropriately set the time quantum, the CPU efficiency will increase. Okay, there will be less context switch. Okay, the response time will be better. So all of the above. The answer is all of the above. Very good. Okay. So let us go to the next one. Okay, so another task.
Should be FCFS.
FCFS. So those who have already studied operating system, they can understand. So can you explain the reason? Can anyone explain why? Your answer is correct. It is FCFS.
Yes, sir, I can explain, sir.
Yes,
So actually, sir, if the round robin, sir, for example, the time quantum for the operation is, for example, we can say, for example, 30 seconds. And then,
Okay.
sir, we have all the operations which are happening. So they have a time period which is much less, for example, 5 seconds, 10 seconds. So if the operation keeps on happening like this, that means, sir, in the single cycle only the entire operation is going to end. So if the single cycle operation is going to end, so there is no interchange and no cycling actually. So
Yes,
it will become
very
fast come
good, very
first.
good. Okay. Okay, very good. Very good answer. Thank you. Okay. So let us go to the next slide. Okay. So this is the priority scheduling as we have already talked. Okay. So in priority scheduling, what will happen? Each process will be assigned a priority. Okay. So, and this will be done by the operating system based on the urgency of the process or the importance of the process. Okay. And priority will be set. So the process with the highest priority, okay, it will go to the runnable state first, and like this it will go on happening. Okay. So how these things can be done? Okay, so for example, like there are some processes which are highly IO bound. Okay, that means they require a lot of input output process and spend most of their time waiting for the IO to complete. So they will spend most of the time for the IO to complete. Okay, so whenever such a process wants the CPU, it should be given the CPU immediately so that it can start the next IO request. Okay, so what will happen? It will be given the CPU. So up to the IO request, up till it encounters the IO request instruction, it will get executed. Now till the time it will wait for the IO, the other process will get executed. So it can be set highest priority. This is a kind of example. The processes which are highly IO bound, that require a lot of IO, they will be given higher priority. The reason is that once they complete their execution till the IO part where they require the input output, okay, they will get removed from the CPU and the CPU will be able to execute another process that is very short, okay, or that is having low priority till the time it will get the IO. Tell me, did you understand this?
Sir, one question, sir. In this
Yes.
priority scheduling, sir, is it non-preemptive or preemptive?
Priority scheduling is actually non-preemptive in nature. Okay. So it can
Yes.
be non-preemptive in case, whatever example I have given, see, whenever the IO is happening, it will leave the CPU. Okay. But in case we have assigned priority numbers to the processes, if a higher priority comes, then the lower priority will get removed.
So that removal happens in the middle of the process by saving the context resources, or it happens after the current process is completed, then and only then the higher priority will be allowed.
See, we are talking here about the priority scheduling. Already the priorities have been assigned and they have been set into the queue. Okay, so in the meantime, what will happen? I am telling about that meantime. Like suppose a higher priority process has come, it is waiting for the IO. In the meantime, another process can get executed. Okay.
Yes.
And remember one thing, in actually what happens, these priorities are dynamically assigned to the processes by the operating system. Like the operating system can make some kind of adjustment also based on the current state and everything. Okay.
Yes, sir.
And there is a good thing about this also. See, suppose a high priority process has come. So what will happen? According to the philosophy, it will go on executing until and unless it has finished, right? So like this, the operating system is making a choice that this particular process will require IO. Okay, and it is making space for the lesser priority processes. So whenever it will go to the your block state, the lesser priority process will get executed. Okay.
Yes, sir.
Okay. So let us go to the next part. Okay. So this is something that has been shown here, how these things are done. Like multi-level queue scheduling is also there based on the type. Like system processes, they have the highest priority. Okay, system processes will always have the highest priority. Then interactive, like I told you, interactive means where IO is required, they will be the next one. Then batch means the processes that are kept in a pool and executed together. Suppose, for example, you can tell payroll generation, this is a batch process. Okay, so payroll of a particular organization of the employee can be generated together. Electric bill generation, all these are batch process. Okay, and student process has the least priority. Okay, this is just an example of a system. Suppose in a system, this type of 3-4 processes are there. This is how the highest and lowest priority will be given. Okay. Now let us go to the next part. This is another problem for you to solve. So multi-level feedback queue are used for which one?
Sir, I think it's option C, sir, to apply the priority which is initially set.
Anyone else? Any idea? Anyone else? Option C is incorrect.
So option D.
Option B.
D, sir, heuristic and statistical approach.
Yes, it is correct. But can you tell the reason? Any idea? Anyone? D is correct, but what is the reason?
Like, sir, in the feedback queue, sir, actually we are finding that when the queue Actually, sir, according to the process allocation, we are going to be giving the CPU to the processors based on priority. So if a higher priority is coming, then that means we will be degrading that queue and allowing another higher priority queue processes to execute. So therefore, it's kind of statistical. This is a rough overview, sir.
Okay, actually what will happen, see, okay, try to understand. So the OS can do one thing, it can increase the time slice of those processes that are coming to the CPU. Okay, it can increase the time slice. So why it is increasing the time slice? So that it can increase the processor efficiency. Okay, but at the same time, when it is increasing the time slice, it is also increasing the chance of few processes to get scheduled, because longer processes will take longer time in the CPU. Suppose I am increasing the time slice. Suppose from 2 millisecond, I am making it 10 millisecond. So a process that is working for 10 millisecond or 8 millisecond, it will take the whole time, isn't it? So there may be some processes for which the chances of getting scheduled will get decrease. That is the concept. So that is why it is a heuristic or statistical approach. Okay. Now, a very good situation that I am going to show you. So what is this? Any idea? What is FCFS scheduling?
So a process which arrives first will be executed first.
Okay. Now you see, can you tell me this first come, first serve scheduling? We have given a burst time here. You know what is burst time? The time it will take to execute in the CPU. Now you see here, if you try to calculate the waiting time. Okay, so we like assume that all these processes has come together to the ready queue. So what is the waiting time? So for if P1 is at the beginning, you can see the waiting time will increase a lot, isn't it? So you know what is FCFS scheduling, you can calculate the waiting time, this is very easy. But if you change the execution order, okay, if you bring P1 at the last, so it can like improve the efficiency of the processor and it can reduce the waiting time for all of them, isn't it?
Yes, sir.
Yes, so that is why I told you this, nothing else. So all of you know FCFS scheduling. There is another example. So what is FCFS? On the processor, the process that will come first, that will be served first. Now the next one, that is SJF. What is SJF?
So any process which has the shortest execution time, that will actually execute first.
Yes. So a process that will have the shortest execution time, that will execute first. Okay. So this is also another algorithm that you can use. So you have to check from here. So which one in this case will execute first? Any idea?
So P4 followed by
Okay.
P1,
So P4 followed by P1,
followed by P3, and lastly
and
P2.
followed by P2. Okay. And finally, we will close our session with the last concept known as this. Have anyone heard of this? So I've given a good diagram for this, a good picture for this, so that you can understand. From the picture, can you understand what is this?
Big elephant going first, and small elephants will have to wait.
What is this? Can any idea? What is the convoy effect in case of operating system?
Sir, large process goes first. It cannot complete execution quickly. All small processes get stuck behind that.
Yes. So actually what happens, suppose assume there is a situation, there is a CPU bound process. Okay. And there are many IO bound processes. Try to understand. There are many, one CPU bound process. How many CPU bound process? Only one CPU bound process. and there are many IO bound processes. Okay, so you assume that the bridge is that CPU, and that big elephant, you see the size of the elephant that is standing on the bridge is bigger than the other elephants, isn't it? Okay, so what will happen in this case? The CPU bound process will get the CPU and will hold it. And during this time, all the other processes, the smaller processes, will finish their IO and move into the ready queue, and they will wait for the CPU. Okay? And in the meantime, again, what will happen? While the processes are waiting in the queue, the IO devices are idle. Eventually, when the CPU bound process will finish the CPU burst and move into the IO device, all the IO bound processes will have very short CPU burst. Okay, and they have to execute very quickly and move to the IO queue. Okay, and during this whole time, what will happen? The CPU sit idle. Okay, try to understand. Again, I am summarizing what is happening. So there is one CPU bound process and many IO bound processes. Okay, the CPU bound process is executing in the CPU and it will hold it. During this time, the IO bound processes that were there, they will complete their IO. Okay, IO related task, whatever is there, and they will come to the ready queue, isn't it? They are waiting for the CPU. Now, while these processes will wait in the queue, the IO devices, what will happen? They are also resources. They will sit idle. Now, when this CPU bound process, the process that is already there in the CPU, it will complete the CPU burst and it will move to the IO device. And other IO bound devices, what will happen? They will get a very less time and they have to execute quickly so that they can move back to the IO queue. And the CPU will remain idle at this time. Okay. Now again, what will happen? The CPU bound process will move back to the ready queue and CPU will allocate it to it. And again, this whole thing will go on. So this kind of cycle is known as the convoy effect, where what will happen? Other processes will end up for one big process to get off the CPU. See, one big elephant is waiting in the bridge and other smaller elephants, they are waiting. Okay. So did you understand the convoy effect?
Yes, sir.
Okay. So based on this, there is a very small question for you. Okay. How would you reduce the convoy effect? Which scheduling algorithm can do this? We have already discussed. You have already discussed all the scheduling algorithms. Which one can solve this?
Sir, shortest job first.
Yes, very
Yes,
good.
yes.
The shortest job first. Yes. So the shortest job first, if I allow the smaller elephants to cross first, they will not take much time and they will cross it. Okay. So we have completed our session. Still, if you have any questions, see, it is not possible for a single class to complete the whole thing. But still, we have done this and we will also be doing this thing in the future. Okay. So we had a great cooperation from you during the whole session. Thank you for attending the class. And if you want to get connected with me, you are always welcome. And if you have any question, you can ask me.
Sir, I have a question. Sir, we have actually seen this multi-level queue scheduling and multi-level feedback queue scheduling. Sir, that what is the primary or main difference between these two types of scheduling? So, can you just elaborate on this ones?
Okay, in queue scheduling that you have seen, okay, the operating system, it is setting the priorities, okay, and it is scheduling. In multi-level queue scheduling, what is happening? There is a kind of feedback, and based on that feedback, it can change the scheduling. Okay, it can change the priority.
That means that in multi-level feedback queue scheduling, the priority is dynamic, and in the other
Yes,
one, the
yes,
priority is constant.
yes.
Okay, sir.
Okay. Okay, so thank you.
Thank you,
Have a
sir,
very
for the
nice day.
session. So one more thing, sir.
Okay.
Sir, would be anticipating a session on memory, sir, memory management in the future.
Okay, well, let us see. We will do that.
Yes.
Okay.
Yes.
Okay, you give the feedback, you tell there, no problem. Okay, if you have any kind of special suggestion, that also you can give. Okay. Okay, so we are signing off for today. Thank you.
Thank you, sir.